In the last lecture, you learned about common concurrency problems and how we can prevent them using standard transaction isolation levels. In this lecture, we're going to review these isolation levels one more time, and I will summarize everything for you in a way that you can easily remember. Let's start by reviewing the concurrency problems. We have lost updates, which happens when two transactions update the same row, and the one that commits last overwrites the changes made earlier. We have dirty reads that happen if we read uncommitted data. Another problem is non-repeating reads, which happen if we read the same data twice in a transaction but get different results. And phantom reads, which happen when we miss one or more rows in our query because another transaction is changing the data and we are not aware of the changes in our transaction. We're dealing with phantoms or ghosts. Now, to solve these four problems, we have four standard transaction isolation levels. Read uncommitted, which doesn't really protect us from any of these problems because our transactions are not isolated from each other, and they can read uncommitted changes by each other. Next, we have read committed, which gives our transactions a bit of isolation, so we can only read committed data, and this prevents dirty reads. But at this level, it is possible that during a transaction, we read something twice and we get different results because another transaction updates the data in between the two reads. So it doesn't really protect us from non-repeatable reads. That brings us to the repeatable reads level. At this level, we can be confident that multiple reads return the same result, even if the data gets changed in the meantime. And finally, we have serializable, which prevents all these common problems. With this level, we can prevent phantom reads, so if data is getting changed in the meantime, our transaction will wait to get the most recent data. Obviously, this puts an overhead on the server because it needs extra resources in terms of memory and CPU to manage the transactions that have to wait. So the more we increase the isolation level, the more performance and scalability problems we're going to experience because more locks will be involved to isolate transactions. So to recap, a lower isolation level gives us more concurrency, so more users can access the same data at the same time. But more concurrency means more concurrency problems. On the flip side, we achieve a better performance because we need fewer locks to isolate transactions from each other. A higher isolation level restricts concurrency, and that means fewer concurrency problems, but at the cost of decreased performance and scalability because we need more locks and resources. So the fastest isolation level is read uncommitted because it doesn't set any locks and it ignores the locks set by other transactions. For this reason, we may experience all concurrency problems. As we go down this list, we get better protection from the concurrency problems, but that also means we're going to use more locks, and this requires more resources, which can hurt performance and scalability. In MySQL, the default transaction isolation level is repeatable reads, which works well for most scenarios. It's faster than serializable and prevents most concurrency problems except phantom reads. So, stick to this unless you absolutely have to prevent phantom reads for a specific transaction. In that case, you can use the serializable level for that particular transaction. As for the other two isolation levels, read committed and read uncommitted, you can use this in situations such as bulk reporting where you don't need precise consistency or when you deal with data that is rarely updated and you want to achieve a better performance. Again, I would say stick to the default for most scenarios and only change the isolation level if you really have to. Now let me show you how to set the transaction isolation level. First, let's view the current isolation level. We're going to use the show variables statement to view the system variables used by MySQL, and then we're going to filter the list to only see a variable called transaction underline isolation. There you go. So the current transaction isolation level is repeatable read. This is the default in MySQL. Now to change the transaction isolation level, we use the set transaction isolation level statement, and then we type the name of the new isolation level, such as serializable. This will set the isolation level for the next transaction. We can also set the isolation level for all future transactions in the current session or connection. So we add the session keyword here. So as long as we have this session or connection open, all the future transactions will have this isolation level. We can also set the isolation level globally for all new transactions in all sessions. And For that, we use the global keyword. Now, if you're an application developer, you have a function or method somewhere in your application that connects to your database to execute a given transaction. You may use an object relational mapper or directly connect to MySQL. Either way, just before executing your transaction, you change the isolation level only for that session or connection, and then run your transaction. So you connect to MySQL, change the isolation level, execute your transaction, and disconnect. This way, other transactions in the database will not be affected. All right, that brings us to the end of this lecture. We're going to see each of these isolation levels in action.